about evaluating and graphing functions for lesson 2. In lesson 1, we talked about identifying a function. What is a function? Today, we're going to talk about evaluating and graphing them, kind of what to do with those functions. Our essential question is, how can you use a function notation to represent a function? So we'll be talking about functions and function notation a lot. So you should be able to answer this question by the end of the lesson. Okay, quick review. In order for it to be a function, it has to pass a couple tests, or really one test, but depending on what we're looking at, whether we're looking at a table, a set of ordered pairs, mapping version, a graph, there's different kinds of tests that we make sure, or in order for it to be a function, it has to pass. Overall, for every input, or every x value, it can only have one output. Another way to think about that, especially with tables and sets of ordered pairs, is there's no repeating x values. Or, especially for graphs, it passes the vertical line test. So it had to be true about one of these items in order for it to be a function. Either there's no repeating x values, it passes the vertical line test, or for every input, there's only one output. So for every x value, there's one y value. Now today, we're going to learn what function notation is. Function notation. The most common function notation is f of x, and that is read as f of x. F of x. Now our f is the name of the function. Where our x is our input value, or our variable that we've been working with. So you can see it in many different ways, and we're going to kind of figure out why we're going to this function notation versus just saying equals y. But the one thing I want you to know is that if I say f of x, that's saying the same thing as y. As in, if I had an equation of y equals 2x plus 3, it's the same thing as saying a second variable, or our output, right? So these are both outputs. The main reason why I want us to remember this is I know a lot of students try to then, once they solve and evaluate a function, they'll try to divide by f, or try to get x by itself. That is very wrong. We are not doing that. F of x is saying the same thing as y. It's our output. F of x is our output. And it can be, a function notation can look different. It doesn't just have to be f of x. It could be g of x, or it could be f of h, or h of t. That's a popular one I've seen before. Or h of x. Our input values can change, just as the name of our functions can change. But they're still function notations. So, if we've looked at a function, or kind of think about functions as a machine, and we have an input, and that goes into a machine, This would be our function. And once it goes through that function of that machine, we get an output. So our input would be our x, or our variable. Our function would be our rule or equation, where our output would be like the y, or for function notation, f of x, or whatever the name of our function is. So in order to evaluate, all you do is substitute, I'm just going to write sub, the input value anywhere you see an x, or whatever the variable input is, or the letter I'm going to say inside the parentheses, and that's talking about in function notations, inside the parentheses, parentheses. So like on our examples over here, we had x, h, t, and x as our input values. So anywhere I see that, I'm going to evaluate, or I'm going to substitute in the given value anywhere I see that letter. So if I was given an example, we're going to do some examples. Say I was given the function f of x equals 2x plus 1, and I wanted to evaluate it for f of 3. So when I talk about evaluating, I read it as f of 3, just like how we read function notation is f of x, f of whatever's in the parentheses. That's how you say it. So f of 3, I want to evaluate that. So everywhere that there is an x, I'm going to put a 3 in our function. Just substitute that value in. So 2 times 3 is 6, plus 1, f of 3 equals 7. So we evaluated this function based on this input value, and this is our answer. Okay, so let's do another example. Say I'm given the function g of n equals 4n minus 2. I want to evaluate it for g of negative 2. So everywhere there's an n in this function, I'm going to substitute negative 2. So g of negative 2 equals 4 times negative 2 minus 2. 4 times negative 2 is negative 8 minus 2. Negative 8 minus 10, or minus 2, is negative 10. So after we've evaluated, we know that g of negative 2, so our function g, that's our name for the input value of negative 2, equals negative 10. One more example. Say I have the function h of x equals x squared plus 2x. So we haven't really dealt with a lot of squares in our solving before, but I think this one is pretty simple. So I want to evaluate for h of 5. Everywhere there's an x, I'm going to substitute 5. So h of 5 would look like 5 squared plus 2 times 5. 5 squared is 25. 2 times 5 is 10. So 25 plus 10 is 35. So after I've evaluated, I know that h of 5 equals 35. And that is my answer. So that is how you evaluate functions. So go ahead and take a picture of your notes, submit that into your journal, and then open up the practice document. I'm going to go ahead and go over a couple of the practice problems. And in order, if you want to go ahead and start looking at the graphing, that is in a separate video. So you can actually see the calculator buttons that I'm pressing. So that is in the second video for lesson 2. But right now I want you to go to the practice document for lesson 2. Okay, so this is the practice document I was talking about. I'm going to go ahead and kind of go over some of these things. Some of the notes are very similar. I'll go through one of each problem, kind of give you an idea of what's to be expected, what steps to follow. And then you should go through, complete the rest of them on your own, and check your work with the answer key provided. Okay, so kind of what we've talked about before. We have our inputs, we have our function, we have our outputs. So looking at the first one, we're going to say 5 times 2x. I'm sorry, 5 as our input for the function of 2x. Well, if I substituted 5 for x, that would be 5 times 2, which would equal 10. Negative 3 times 2 would be negative 6. So we'll use those here again in just a second. But this is kind of a recap of what the function notation is. X is the input value, and f of x is read as f of x and is equal to y. It's saying the same thing as our output value. So looking at A up there, we're going to write the rule of the function in function notation. So we know that the name of it is f of x. That's what it told us up there. So f of x equals, and then our machine, our rule, the equation was 2x. We don't have to worry about these other input values right now because we've got that covered by the parentheses. That tells me we're putting in x for now. So you can do B by yourself on that one. Evaluating functions. To evaluate f of x equals 3x plus 9 for x equals 5, you substitute 5 for the variable x and write f of 5 equals 3 times 5 plus 9. Therefore, f of 5 equals, we get that by 15 plus 9. That would equal 24. Okay, so same thing that we've been doing. I am going to work number 2, but I want to go ahead and remind you that on number 1, don't forget to distribute that 6 when you evaluate. But here's our function. Remember, this is the name. This is the input value. So I want to evaluate it for g of 1. So everywhere there's a x, I'm going to put 1. G of 1, well, I guess I don't have to rewrite that since it's written right there, is equals 1 squared minus 12. 1 times 1 is 1, minus 12 would equal negative 11. So g of 1 equals negative 11. Okay, same thing for g of negative 3. Everywhere there's an x, I'm going to put negative 3. It's only in one place. All right, so with the negative sign, negative 3 times negative 3 is equal to 9 minus 12. 9 minus 12 equals negative 3. So g of negative 3 equals negative 3. Okay. On this question right here, it's really good to think about. Remember, you cannot divide by a 0. So what value of x cannot be evaluated? Okay. Next, let's do number 5. Given h of x equals 5 times x plus 3 squared, what is the value of h of negative 5? Okay, so I know that this one sounds scary, but we're going to use our order of operations. We're going to substitute negative 5 everywhere we see x, and then it'll actually come out to be pretty easy. Okay, so h of x, let me go ahead and say of negative 5. We'll go ahead and put that in. So everywhere there's an x in this function, I'm going to substitute negative 5. So equals 5 times negative 5 plus 3 squared. Okay, order of operations. Think about PEMDAS. First, we're going to do what's inside the parentheses. Negative 5 plus 3. Well, they have different signs, so I'm going to subtract them and keep the bigger sign. So that would be negative 2 squared 5. I'm going to square it first. I did parentheses. Now I need to do exponents. Negative 2 times negative 2, which is what squared means, is 4 times 5. 5 times 4 equals 20. So h of negative 5 equals 20. Okay, so now we're going to look at number 9. How do we evaluate on a graph? This is the easiest one because we just look for our input value or our x value. So remember, if f of x is our output value or our y, and this is our x, we want to look for the ordered pair of x, y. So what is that y value? So if we're looking at x of negative 4, I'm going to go find x of negative 4. That's my x of negative 4. So where on this function does it hit negative 4? What y value? It'd be easier just to look right there. So what y value does our function hit when x is equal to negative 4? And the answer would be 6. So our answer, our evaluation of f of negative 4 equals 6.